Okay, who knows what an asymptote is? Come on, y'all. Somebody from algebra 2. It's a dashed line. What does it represent, or what does it do to the graph, or what? Describe this dashed line to me a little bit better than just a dashed line. Is it a part of the graph? No. So what does it do? It's imaginary. It's like it does. It bounds it. You're exactly right. It's a boundary that the graph comes really, really close to, and it hugs, but it can never cross over. Okay? And so you've probably seen them. We can have horizontal asymptotes or vertical asymptotes. Maybe my graph does something like this when you did growth and decay. So that graph would come in and hug that asymptote, get really, really close, but it'd never cross it or actually touch it. Okay? And that's what it means to be an asymptote. So we're going to talk about, we've been talking about functions and all these different analysis parts that we do on functions. And so the next step is to look at the horizontal and vertical asymptotes that a function may have. So again, that one is horizontal. It could be vertical. It could look something like that. But we're going to look how to find them algebraically. Y'all ready? All right, well, ready or not. We'll do horizontal asymptotes first. They're the easiest. So I'm not going to be looking at the graph. I am going to be looking at the equation to find the horizontal asymptotes. And here's what I do. I set up 3 different scenarios, and I'm going to classify based on those scenarios. And I'm going to use Miss Twitty's method, or her wording here. I could be 3 different things, and I'll explain to you what these mean. I could be top-heavy, bottom-heavy, or the same. And what I'm looking at when I'm talking about these is I'm looking at the degree of the top and the degree of the bottom. So this is really when I'm talking about a fraction, okay? Like my equation is in a fraction. For example, f of x equals 3x over x squared plus 1. So before I can look at that, I guess we need to make sure everybody knows what degree means. What does degree mean? It's the power, the biggest power there. So what would the degree of the top be here? 1. What would the degree of the bottom be? 2. So top heavy, we're going to say that means the top degree is bigger than the bottom degree. Bottom heavy, we're going to say that the bottom degree is bigger than the top degree. And then the same means they have the same degree, top and bottom. We all clear on what that means? So in the example I just wrote out to the side, how would you classify that one? Bottom heavy. We all agree? All right. If our function is top heavy, we have no horizontal asymptotes. There are none. If I am bottom heavy, I have one and only one horizontal asymptote, and that horizontal asymptote is at y equals 0. Where is y equals 0? Right in the middle. It's the x-axis itself, right? So this one, because we're bottom heavy, whatever else it does, it's got an asymptote right here. Everybody okay on that? When they're the same as whenever you really have to do a little bit of work. If they are the same, then I take the leading coefficient of the top. I'll write it out this time. Leading. Oh, no. Thank you, Matthew. Appreciate your enthusiasm there. I do the leading coefficient of the top divided by the leading coefficient of the bottom. So what is the leading coefficient, in case you forgot? The number in front, the number that's hooked to the term with the degree. So I want the coefficient of the term with the biggest exponent. And we'll do an example of all of these so you can see.
Is that an LC?
Yes, LC. I just didn't write out leading coefficient. All right, let me show you an example. Does this one have any horizontal asymptotes, and if so, where are they? So you first have to decide, is it top heavy, bottom heavy, or equal? Equal. Why? Biggest exponent, right? So now, if they're equal, what does it say that I do? Exactly. So what's the leading coefficient of the top? 2. What's the leading coefficient of the bottom? Ooh, -1. Remember, leading coefficient is always hooked to the term with the biggest exponent. So really, what you want to do is think about this in standard form, because in standard form, that's when it leads the equation. So this means I have a horizontal asymptote at -2. Does that make sense, what we did? That's the hardest one to do when they're the same. Let me just graph it real quick for you and show you this asymptote. You'll be graphing these a lot. Careful when I'm a fraction. So you want to put these parentheses in here. 2x squared divided by 4 minus x squared. I'll do a zoom 6. And I should have a horizontal asymptote at -2. Do you see where this asymptote is occurring here? See how that graph is trying to get as close to -2 as it can, but it's not actually hitting -2. That tells me there's an asymptote. If you hit trace, give it a second. All right, so watch your numbers, watch your y values here as I go. See how it's getting closer and closer to -2? It'll never actually be -2. It's going to get really close, but it's not actually going to be -2. No. Never. All right. Thank you for that, Matthew, but I think it'll be okay. I'm positive. All right. Let's look at one more. Let me show you vertical first, and then we'll do horizontal and vertical asymptotes. These are the hardest. For right now, we are going to only focus on when it's a fraction, okay? And so my vertical asymptotes, so up and down, are going to occur when the denominator, what's the denominator? What's the denominator? The bottom. They're going to happen when the denominator equals 0.
Please pardon this interruption.
All right, so vertical asymptotes when the bottom equals 0, right? Mm-hmm. All right, so we're going to be looking at some kind of things we got to find zeros of. Look at this one. Now, before we talk about the vertical asymptotes of this one, let's talk about the horizontal. Does it have any horizontal? If so, where? I hear yes. Bottom heavy, and bottom heavy tells us that the horizontal asymptote is where? Y equals 0. So I already know that y equals 0 is a horizontal asymptote. Is anybody confused about that? But vertical asymptote, look what I'm looking for. Well, what's the denominator? Will it ever be 0? Is there any value of x that will make that 0? In other words, how do you solve that? Please tell me that we spent chapter P efficiently and y'all know how to solve that. It's a quadratic and it equals 0. What should we do? Come on, guys, please. Factor it. I would definitely factor that and solve it. If you factor and solve this, how does it factor? What multiplies? Leading coefficient's 1, so it's an easy factor. What multiplies to -2 but adds to -1? -2, +1. Y'all did the factoring well on your test, so I know y'all can factor. All right. I hope y'all can factor. I'll take it out step by step here. First two, what's the GCF? X. What's left? How about these second two? And so it leaves me x minus 2. So what does this look like factored? Order doesn't matter, huh? Go ahead. You need to turn one off. Now, can you tell me what the zeros are? -1 and 2. Because if I solve them each, I would have 2 and -1. So here's what this tells me. I've got 3 asymptotes altogether. I've got a horizontal asymptote, y equals 0. I got 2 vertical asymptotes, 2 and -1. So whatever else is going on with this graph, y equals 0, x equals -1, and x equals 2. Does everybody see how we got those? Okay. What if that wouldn't factor? Quadratic formula. Quadratic formula always works. You might not have, okay, have y'all done this yet? Let me just confirm this graphically because you will have to sketch a graph on these. So let me just show you what this looks like on the graph. And I should see all 3. And I started us out with a little bit of a harder one as far as solving the bottom. Minus x minus 2. You see why I have an asymptote at all those places? Okay. Here's the vertical, the -1 and the 2, one way. The equation, I just typed it in y equals. Oh.
See, right there is changing.
It's supposed to be right where?
Right in the top box.
I know, I don't know why it delays. I don't know what's going on. But there's my y equals 0, and even though this goes through right there, that asymptote, it's these wings on the end that it's really applying to there. And then -1 and +2. So they're both there. Does that make sense to everybody how we got that? All right. The bottom, it may be a little bit easier. You may encounter something that looks like this. I know, it's tough. How about horizontal asymptotes for this one? It's bottom heavy, which tells me what? Y equals 0. How about vertical asymptotes? Make the denominator equal to 0, but what happens when you do that? I go to solve. What happens? I. Am I graphing any imaginary numbers here? No, I'm on a real number plane, not imaginary numbers. So I say there are no horizontal asymptotes, and that's okay. Every graph does not have to have them. Y'all okay on that? Horizontal and vertical asymptotes? All right, one more thing to show you. This is the last little snippet of analysis. This is called end behavior. I hope you remember this from Algebra 2.
You said it was not
No horizontal, yeah. Huh? X. It's no vertical. You're right. Sorry. All right. How many of you remember end behavior? A little bit? All right, here's what end behavior does. There are two ends to every graph, and we're going to look at both ends, and that's really what we're going to focus on right now. Did it go away? You didn't get taught end behavior? Okay, well, here's what end behavior does. End behavior looks at the ends of the graph, at what's going on at the ends of the graph, all right? Let me just show you first. Let's take a look at a really, really easy graph. Let's say this was my graph. Okay. To describe the end behavior here, I'm going to look at what both ends of the graphs are doing. Both ends of the graph are doing. So here, I've got a right end and a left end. Do you agree with that? All right. So I need to describe it two ways. So I'm going to use this little mathematical sentence. And I'm going to say as x, and I'm going to use this arrow. This arrow means approaches, gets close to. As x approaches infinity. Now, infinity is a conceptual kind of thing. So as x gets really, really big, in which direction does x get really, really big? It's only one way. Right, left, up, or down. Which way does x get really, really big? To the right. Right? If this is my x-axis, x is 1, 2, 3, 4. It gets bigger and bigger and bigger the further to the right I go, right? Does that make sense? So if I said as x approaches infinity, this is telling me the right side of the graph. What does the graph itself, which I'm going to call f of x, what do you think it approaches? So now think about y. Why? It's going down. Okay? This means down. Because y gets bigger up and smaller down. But I told you there's two ends, so I need to describe the other end also. So now, as x approaches negative infinity, so that means on the left side of the graph now, as x gets smaller and smaller and smaller and smaller, what does the graph do? Does it go up or down? So up is positive. That's the end behavior of the graph. Does that make sense? For these, all of this is exactly the same for everyone. What's changing is this. Let me give you one graph, see if you can do it, and then I'll be done. You hate these? Why? Now, I will tell you that the positive and negative infinities, if there's an asymptote there, it could approach that asymptote instead. Okay? So if it went like this. I still have two ends, right? As x approaches infinity. So look to the which side? Right. On the right side of the graph, what is it doing? What's it getting close to? Look at the right side. There's an asymptote there, right? And the further I get, the closer that graph gets to the asymptote. So this time it's not approaching negative infinity. What instead is it approaching? 0. Look at the right side of the graph. Will it keep going down forever? No. It's gonna, that asymptote is holding it in place right there. So it's getting closer and closer and closer and closer and closer. It approaches it, but it sure won't ever touch it. How about the left side? What's the graph do on the left? It goes up. Really fast it goes up, right? So it approaches positive infinity. in behavior. What do you think? Okay.